Okay, so part two of our notes is going to be radiation. Radiation, not radiation. Woo! Radiation. So, radiation is the byproduct of a nuclear reaction. So, when we talk about this, we talk about like isotopes. So, isotopes are atoms that have the same element with different number of neutrons. We've talked about isotopes a long time ago back in the first semester. So, atomic number is your number of protons. Your mass number is the number of protons and neutrons. So, your isotopes are going to have different mass numbers than your regular ones that you see on the periodic table. So your isotope is, so two ways of writing the isotope is your 14 carbon 14 or 14C over your number, so 6. So isotopes are the same element, they behave the same way, they are just found differently in the environment. They are also found differently in different types of reactions. The biggest thing that we talk about with this would be like carbon dating. So carbon dating, you use different types of carbons to date how old subjects and objects are. So radioisotopes, isotopes have an unstable nucleus. Now radioisotopes become stable by emitting radiation. So radioactive decay. So this is a spontaneous process. There's transmutation, meaning that this element transforms into a different element over time. It is a slow decay. It's not a reaction like a fission or fusion process. It is just slowly decaying into something else. So radiation can be emitted through a source, through an intermediate space. They can go through these things. So it depends. Something has to be lead shielded if you don't want to gain any radiation from it. Radiation. So there is this radioactive decay from your batteries in your cell phones. Over time, they will decay or stop working as well as they used to, and you are basically carrying radiation around all the time. So atoms become stable by giving off your particles and energy. So or either neutrons, protons, energy, or some sort of radiation that decays it into something new. Non-ionizing radiation is different than ionizing radiation. So non-ionizing will not have a sufficient energy to produce ions, and these are your microwaves, radio waves, the visible light you see. These are all types of radiation. They just don't produce ions. So ionized radiation has sufficient energy to produce ions. So exposing ionizing radiation comes from like X-rays, cosmic rays, radon. Radon is actually a substance that can be very harmful to you. If you haven't had your basement tested for radon, that can cause actual lung cancer. I actually had mine tested, and it was 4 times the acceptable limit. So we had to have a radon fan put in our basement to blow out all of that. That happens when uranium decays underneath your uh, house and produces this radon. So these are alpha, beta, gamma, and X rays, and we will discuss each ray. So non-radioactive radiation is electromagnetic radiation. So this is your X rays. So when you do if you've ever had a broken bone or a torn ligament, when you do a CAT scan, that's the radiation that goes through your body to show that there is some sort of that lights up your bones and things to show that you have a fracture or if you have a torn ligament. So radioactive radiation originates from the nucleus. These are your alpha, beta, and gamma radiations. So alpha particles consist of a helium nucleus. So helium 4. They have a charge of 2 and a mass of 4. So it is not very penetrating. It can be stopped by paper or skin. So you don't have to have a heavy shield against alpha radiation, alpha particles. And this is how we write the loss of an alpha particle. So the decaying of 2 creates helium-2, your alpha particle, and then we have thorium, that is the other one that is created from it. All right, so beta. Beta are fast-moving electrons emitted from nucleus. So this is the decomposition of a neutron. And so this is decomposed into a proton and an electron. So our electron is moved off, or we have our beta particle. Charge is negative. There is no mass. It can be stopped by aluminum foil or wood. So when we have carbon that decays, it'll decay into nitrogen and an electron. This is how we show the loss of a beta particle. So the atomic number is increased by 1, but the mass number stays the same. So gamma rays. So what happened to Bruce Banner to create the Incredible Hulk? This is an electromagnetic radiation released with alpha and beta. So the symbol is gamma. Gamma's charge is 0, 0. Loss of gamma radiation does not emit and does not affect atomic or anything like that. So penetrating power, they travel at the speed of light, and they pretty much penetrate anything. It takes several feet of concrete or lead to do this. So when you have a very radioactive substance, your gamma rays are what can be most harmful. That's why we have them wrapped in things like lead and concrete to make sure. So when we have a nuclear reactor, we try to cover it in feet and feet of concrete and inches of lead. So the barrier that they have put around Chernobyl, because of how much gamma radiation was being released, is feet upon feet of concrete that have been taken in. This is the end of part 2. So part 3 will be for next week. I will, if you have any other questions, please let me know. I'll talk to you later.